Hello and welcome back. Today we're going to be talking about zero and negative exponents. Our objectives is that by the end of this video you should be able to know and apply the zero exponent property, and you should be able to know and apply the properties of negative exponents. So to our first objective, we need to remember what happens when we divide something by itself. 25 over 25, if you'll remember, is 1. And x to the fourth over x to the fourth is also 1. Now you may be asking yourself, what does this have to do with the zero exponent property? Well, let's take a look. When we apply the quotient of powers property, that is, subtract the exponents, what will the exponent be of the x in the above example, or the example below? X to the fourth over x to the fourth would be x to the 4 minus 4, which is x to the 0. But wait a minute, there seems to be a bit of an issue here, because above we had x to the fourth over x to the fourth, and that gave us 1. The point I'm trying to make here is that if x to the fourth over x to the fourth equals 0, and x to the fourth over x to the fourth equals x to the 0, then that leaves us with one conclusion to make, that x to the 0 has to be equal to 1. So this leaves us with the zero exponent property. I know that one example is hardly a proof for every example, but it was just an introduction to let us know that anything to the 0 power is 1. Let's look at a few examples. 5 to the 0. Well, 5 is being raised to the 0 power, so that makes the whole expression equal to 1. What about this large number to the 0 power? Well, it is also 1. Okay, well, what about any number or a variable to the 0 power? It's also 1. Okay, what happens if you take a base of x to the 5th and raise that entire base, since it's inside the parentheses, to the 0 power? It is also 1. Okay. Well, maybe this doesn't apply when it gets really big. So we've got this very large expression inside of our parentheses, and outside the parentheses we have a zero exponent. That means that everything inside of the parentheses is being raised to the zero exponent. Well, it's also 1. The key is anything to the 0 power is 1. We're now into our second objective of the day, which asks us to know and be able to apply the properties of negative exponents. First key question for working with negative exponents is, how do you write the reciprocal of a number or variable? Well, it's commonly said to take the reciprocal of a number or a variable, you just flip the number or variable upside down, or you flip the fraction. Let's look at some examples. To take the reciprocal of 2/3, I take the fraction and flip it upside down, giving me 3 over 2. What about the reciprocal of 4? Well, since 4 is not a fraction, I can make it a fraction by doing 4 over 1. This does not change the value of 4, and taking the reciprocal of 4 over 1 just makes it 1/4. What about the reciprocal of x? Again, I can make it x over 1, which means its reciprocal is 1 over x. The reciprocal of x squared is 1 over x squared. We're now going to get to our negative exponent property. Note, when we are asked to simplify an expression, we usually change all the negative exponents into positive exponents by applying the following property. To change a negative exponent into a positive exponent, we take the reciprocal of its base. So let's simplify the following two expressions. Looking at the first one, we have 2/3 to the negative 1. So again, to simplify, we change a negative exponent into a positive exponent by taking the reciprocal of its base. So since our base is 2/3, we take the reciprocal of it, we get 3 over 2. And our negative exponent, which is a negative 1, changes to a positive exponent, or positive 1. We could rewrite that further because an exponent of 1 does not have to be written, leaving us with just 3/2. What about x to the negative 2? Again, to simplify, you need to change the negative exponent to a positive exponent by taking the reciprocal of its base. So since our base is x, we take the reciprocal of x, which is 1 over x. And our exponent changes from negative 2 to positive 2. Notice that the exponent stays with the base, it does not go to the numerator. We're now going to get to a few more examples to help us better understand this negative exponent property. Let's take a look at that first example. 3 times x to the negative 2. In order to simplify the expression, we take the reciprocal of the base, which is our x. Notice 3 is not part of the base. 3 in this case is a coefficient of x to the negative 2. So we're going to take this reciprocal of x. We get 3 times 1 over x squared. Again, the only thing I took the reciprocal of was the x because it was the base that was being raised to the negative 2, not the 3. We can simplify this further by doing 3 over 1 and multiplying our two fractions, giving us 3 over x squared. Now, if we change this problem up just a little bit by putting parentheses around the 3x, notice that this makes all of 3x our base. So negative 2 is the exponent of our entire base, which is 3x. So to change that negative exponent to a positive one, we take the reciprocal of our base, so it becomes 1 over 3x, and our exponent changes from negative 2 to positive 2. Try the third and fourth examples on your own. The third example was a little bit more complicated because we had to simplify the inside of the parentheses first, leaving us with 4x to the 7th to the negative third. Remember our property from last video, which asked us to always simplify the inside of the parentheses first. Then, we can change the negative exponent into a positive exponent by taking the reciprocal of the base. So it becomes 1 over 4x to the 7th to the positive third. We can simplify this yet a little bit further by applying our exponent rule we learned last time, giving us 1 over 4 to the third x to the 21st. I apologize, in the previous example, I forgot to distribute my exponent, giving me 1 over 3 squared x squared. Let's look at that last problem. You should have just gotten 1 over x. Alright, I've got another key question for you to help us again understand yet another detail with negative exponents. How do negative exponents behave? That is, what happens to them and their bases when they are already in a fraction? Let's take a look. What happens if I have 1 over x to the negative 1? Now, what I'm about to show you is a bit technical. You don't have to know it to apply the property I'm going to show you, but it is useful in helping us understand why the property works. So, if I have 1 over x to the negative 1, what's your base? Well, your base is x, so we take the reciprocal of it. We get 1 over x. In order to divide a fraction by a fraction, we can multiply the top fraction, which is 1, times the bottom fraction, which is x over 1, the reciprocal of the bottom fraction. This leaves us with 1 times x over 1, which is just x. What I really want you to take from this is that if you have a negative exponent in the denominator of a fraction, you can move the position of the base from the bottom to the top, and it changes the exponent from negative to positive. Let me show you just one more example. What happens if I have 2 over x to the negative 2? Well, I could change that negative exponent to a positive exponent by moving my base, which is x, from the bottom to the top, and changing the negative 2 to a positive 2. leaving me with 2 times x to the positive 2. Another way to put the previous example is that if you have a base with a negative exponent in a fraction, you can change the position of the base from the top to the bottom of the fraction, or vice versa, then change the exponent from negative to positive. Note, when simplifying, we're always going to change our negative exponents to positive exponents by moving the bases first. This can make simplifying much easier. Let's take a look at a couple of examples. So again, we're going to move our negative exponents first by using the property we just learned. So x to the negative 3 would go to the top, giving us x to the positive 4 and x to the positive 3. Since there's nothing left on bottom, we do not need to write a denominator. We can simplify this further by giving us x to the positive 7. Let's look at another example. X to the negative 2 and y to the negative 5. Those are our negative exponents. To make those negative exponents positive, we move their bases from top to bottom and from bottom to top. So let's see what happens. We still have y to the third on top times y to the positive 5 moved up over x to the positive 2 is now on bottom, and x to the 11. This gives us y to the 8th over x to the 13th. Let's look at that last example. We have a bit of an issue because there's a negative exponent outside the parentheses. We need to apply that negative exponent property first by taking the reciprocal of the base, meaning all this stuff on the inside. To do that, we get x to the 5th, y to the negative 2, over x to the negative 3, y to the positive 4, because this negative exponent caused the base to flip upside down. Now, that changed the negative 1 to a positive 1, which we don't have to write. Now we can simplify this problem like we did the previous one. Go ahead and try to simplify this problem on your own, and press play when you're ready to see the answer. Okay, you should have gotten x to the 8th over y to the 6th, because the negative 2 went down and became positive 2 and added to the 4. The negative 3 went up and became positive 3 and added to the 5. Alright, I have several examples for you to try on your own. Go ahead and press pause. When you're ready to see the answers, go ahead and press play. For our first one, we're going to get a to the 5th times 1, because ab to the 0 power is 1. This just leaves us with a to the 5th. Second example, x to the negative 3rd is the same thing as 1 over x to the positive 3rd. Third example, our base is x to the 4th, so we get 1 over x to the positive 4 to the positive 2, leaving us with 1 over x to the 8th. For our fourth example, we're going to get 5 times 1 over x to the positive 7, which is the same thing as 5 over x to the positive 7. Another way to look at that problem is you could have just taken the x to the positive or negative 7 and moved it to the denominator, making it a positive 7. For the fifth example, we have 2x to the 5th now on bottom, positive 4 exponent with a 1 on top, leaving us with 1 over 2 to the 4th x to the 20th. Sixth example, we move our negative exponents to the top from the bottom and make them positive. This leaves us with x to the 6th, x to the 4th, y to the 5th, y to the 7th, which is the same thing as x to the 10th and y to the 12th.